They laughed, quietly, but with the confidence of men certain of their mathematics. In early 1955, inside the vaulted operations room of the Soviet PVO Strany, a colonel from the 2nd Directorate reviewed an intercepted American aerospace briefing. The document mentioned an aircraft designed to fly above 70,000 feet. He smirked, tapped the paper with his pencil, and declared to the room, "Let them dream. Aluminum cannot survive the temperatures, fuel cannot sustain combustion, and their pilots cannot survive the altitude." The room nodded. To them, the United States had proposed a fantasy, an aerodynamic ghost that defied altitude, physics, and Soviet experience. By that point, Soviet radar engineers had spent a decade refining their G-band systems to track American bombers averaging 25,000 to 36,000 feet. Their interceptors, the MiG-17PF and the emerging Su-9 prototypes, were optimized for thick air, predictable bomber corridors, and the expectation that any reconnaissance aircraft must trade altitude for speed. The PVO's annual models insisted that the highest sustainable operational flight level for any manned reconnaissance platform was no greater than 21 kilometers. Anything beyond that was considered a theoretical edge case for laboratory gliders, not metal aircraft operated by intelligence officers. What they underestimated was not American aerodynamics, but American capacity. On the morning of July 4, 1956, the first operational U-2 crossed into Soviet airspace. It drifted over the western USSR at an altitude the Soviet control officers refused to believe. Radar operators in Belarus reported a faint, intermittent trace, a needle-thin line flickering at the top edge of the radar scope beyond the calibrated range markings. One operator later recalled that the altitude return looked like a system malfunction, not a real aircraft. The Soviet Air Defense Command tried to scramble MiG-17s from Baranovichi. Their ceiling collapsed at 45,000 feet. Pilots radioed back in frustration. "The target is above us, impossibly above us." Inside the Kremlin, the first classified briefing hit the desks of senior leadership before noon. An unidentified American aircraft had flown unchallenged across hundreds of kilometers, photographed strategic sites, and exited intact. Even worse, subsequent reports confirmed that no interceptor, no missile battery, and no radar station had achieved a track stable enough to vector an attack. It was the first American aircraft the Soviets admitted they could not see, physically, electronically, or doctrinally. The shock was immediate. A deputy commander of the PVO scrawled on the margin of a situation report, "If altitude is their shield, we have no sword." In that moment, years of confident ridicule dissolved. The mathematical certainty that Americans could not manufacture an aircraft capable of sustained flight above 21 kilometers evaporated in a single overflight. This was not merely the revelation of a new aircraft. It was the rupture of an entire worldview. Because to the Soviet mind, raised on industrial scarcity, limited aluminum alloys, and incremental aeronautical progress, such a machine was not supposed to exist. It violated their assumptions about American engineering discipline, resource constraints, and technological pacing. Worse still, it exposed the fundamental blind spot in Soviet strategic analysis. They underestimated the United States not in intellect, but in industrial elasticity. As American pilots cruised above 70,000 feet, Soviet generals realized their mockery had been a form of self-defense, a refusal to imagine a country capable of outproducing its engineering doubts. And as the U-2 slipped beyond the reach of every MiG clawing vainly at the thinning atmosphere below, the Soviet leadership confronted an unspoken truth. An empire built on planned efficiency had just been outmaneuvered by a nation built on surplus capability. For the first time in the early Cold War, the Soviet Union was forced to admit that America had created something beyond their predictive models, beyond their radar, and beyond the altitude where their confidence once lived. The Soviet confidence did not emerge from arrogance alone. It emerged from a coherent, internally consistent logic. One constructed from decades of designing weapons in a nation defined by scarcity. To understand why Moscow dismissed the possibility of an American aircraft operating above 70,000 feet, we must enter the intellectual framework of the Soviet aerospace establishment in the early 1950s, a world where every gram of metal, every liter of fuel, and every hour of wind tunnel testing was bound by systemic constraint. In the Soviet doctrine of the post-war decade, altitude was not a frontier. It was an economy. Soviet engineers believed that every kilometer above 15,000 feet demanded exponential penalties. More fuel, more structural reinforcement, more pilot life support mass, more thermal instability, more drag variations. In their minds, altitude was a luxury the Soviet Union could not afford to pursue beyond the margins of operational necessity. And because they could not afford it, they assumed the Americans could not industrialize it. The PVO's predictive models reflected this mindset. Their calculations used Soviet-available aluminum alloys, Soviet fuel chemistry, Soviet avionics weight constraints, and Soviet engine performance curves. When these calculations showed that sustained flight above 21 kilometers produced catastrophic design inefficiencies, they accepted the result as universal truth. They believed physics itself had spoken, when in reality only Soviet industrial limitations had. Thus, Soviet analysts made what they considered a rational assumption. No nation, not even the United States, would pour industrial resources into building a reconnaissance aircraft so specialized it could only survive at altitudes where even minor turbulence could snap a wing. They further believed American aerospace firms were bound by their own economic rationality. Profit incentives, congressional oversight, industrial competition. The Soviets projected their constrained world onto a wealthy superpower that did not operate under the same rules. This flaw in reasoning led them to a second critical misjudgment. They assumed the United States, like themselves, would prioritize incremental improvement rather than radical divergence. The Soviet Union had been improving its interceptors by iterations. The MiG-17, MiG-19, and upcoming Su-9 followed a linear path of higher speed and marginal altitude gains. From their perspective, American designers would do the same, building faster, lower, more robust aircraft similar to the B-57 or RB-47. A leap into the stratosphere seemed wasteful, impractical, and strategically excessive. Furthermore, Soviet resource allocation reinforced this worldview. With industrial capacity stretched thin across tank production, nuclear weapons, early ballistic missile programs, and agriculture machinery, the notion of devoting an entire industrial pipeline to a near-weightless glider-like aircraft made little sense. Their reconnaissance assets relied heavily on ground infiltration, human intelligence, and broad coverage radar systems. The idea that an aircraft could render these systems obsolete by cruising at 70,000 feet simply exceeded their conceptual bandwidth. Even radar doctrine contributed to the miscalculation. Soviet early warning systems of the early 1950s were built with the assumption that any aircraft worth detecting would fly within a predictable altitude band. Their long-range P-20 and P-30 radars had technical ceilings tied to the curvature of the Earth and the ionospheric behavior of their chosen frequencies. Echoes above 18 kilometers were so faint and unstable that operators dismissed them as meteorological reflections or cosmic interference. This fostered an institutional blind spot. If the radar could barely see it, then the aircraft probably didn't exist. By the time the United States began testing the U-2, Soviet analysts still believed they understood American constraints. They had observed American heavy bombers reaching ceiling plateaus around 40,000 feet. They saw U.S. engine designs prioritizing thrust over high-altitude efficiency. They watched American fighters develop around speed, not stratospheric endurance. Everything pointed toward predictable American industrial choices. But the Soviet mistake wasn't technical. It was philosophical. They assumed a nation with more resources would think like a nation with fewer. They imagined American industries obeyed the same scarcity logic that governed Soviet planning. They believed the ceiling of Soviet industry was the ceiling of human capability. That logic was shattered the moment the U-2 appeared. For the first time, the Soviets realized that the United States did not innovate to solve a constraint. It innovated to transcend it. Its aerospace sector had the spare industrial bandwidth to pursue an extreme high-risk program. It had the supply chains to produce exotic metallurgical solutions. It had the research institutions to break aerodynamic conventions. And most importantly, it had the economic freedom to attempt something inefficient if that inefficiency served a strategic purpose. What Soviet analysts interpreted as impossible was simply expensive. And for the United States in the 1950s, expensive was not a barrier. This ultimately was the root of their error. They failed to see that American industry did not follow Soviet rules. It was not bound by scarcity. It was not limited by central planning. It did not need to make every innovation serve a dual-use purpose. It could afford specialization. It could afford redundancy. It could afford risk. And so when the U-2 rose to 70,000 feet, it did more than outrun the MiG-17s. It outran Soviet assumptions about what a superpower could build when its industrial engine had no constraints. The Soviet Union had miscalculated not because they lacked intelligence, but because they lacked visibility into the one domain where the United States held an overwhelming, almost invisible advantage. The industrial scientific ecosystem that made the U-2 possible. To the Soviets, the aircraft seemed like a miracle of aerodynamics. To the Americans, it was the predictable output of an economy engineered for surplus, experimentation, and speed. At the center of this ecosystem stood the Skunk Works, Lockheed's clandestine rapid development division. Under Clarence Kelly Johnson, Skunk Works operated with a development tempo that defied Soviet comprehension. In the 5-year window from 1950 to 1955, Soviet design bureaus averaged 2 full-scale prototypes per year for their advanced interceptors. Skunk Works, by contrast, produced 17 major airframe studies for the U-2 alone, discarding 14 of them in weeks, not years. Their iterative cycle moved 8 to 10 times faster than the Soviet OKBs, not because American engineers were inherently superior, but because they operated inside an industrial architecture designed to remove friction. No bureau politics, no resource scarcity, no multi-year approval delays. This workflow was reinforced by an American supply chain that Stalin's successors could not replicate. The U-2 required high-purity titanium, lightweight composites, precision machined spars, and fuel additives that maintained thermal stability at stratospheric temperatures. The CIA quietly redirected U.S. chemical plants to produce a new high-flashpoint kerosene JP-7, whose thermal properties were so exotic that Soviet analysts in 1956 insisted no such fuel could be mass-produced. But the United States did mass-produce it, because its petrochemical sector could sustain parallel research lines without interrupting civilian production. In the 1950s, the U.S. refined over 9.5 million barrels of petroleum per day, more than 4 times the Soviet total, giving it the chemical flexibility to create custom fuels without compromising strategic reserves. Then there was the engine, the Pratt & Whitney J57. Soviet engineers studied fragments of the J57 recovered from various intelligence channels and dismissed it as inefficient at low altitude, unaware that it had been optimized for thin air at the very edge of the atmosphere. The J57's compressor stages were engineered with tolerances a Soviet factory could not match at scale. American metallurgical refinements allowed the blades to maintain structural integrity at extreme temperature gradients. These manufacturing tolerances, measured in thousandths of an inch, were supported by a machine tool industry producing tens of thousands of precision lathes and mills annually. By comparison, the Soviet Union, with far fewer precision machining centers, had to ration its high-accuracy tools across multiple programs, slowing every design cycle that depended on them. Even more decisive was the bureaucratic structure behind the U-2. Unlike the Soviet Union, where military intelligence and industry competed for priority, the United States could unify those elements under a single mission. The CIA contracted Skunk Works directly. The Air Force supplied test facilities and pilots. The State Department arranged cover stories and diplomatic buffers. The Atomic Energy Commission provided instrumentation. No Soviet program could draw from that many institutions without triggering political infighting and resource bottlenecks. This coordination enabled speed that the Soviets found incomprehensible. From first concept sketch to first flight, the U-2 program required 8 months. The Soviets required 5 to 7 years to move an advanced reconnaissance airframe from concept to prototype. This difference was not merely bureaucratic, it was industrial. The United States had the factories, the subcontractors, the materials, the tooling, and the workforce to build a revolutionary aircraft on demand, without cannibalizing other programs. Even the aircraft's most mysterious quality, its weight, was a byproduct of industrial excess. The U-2 weighed just over 16,000 pounds empty, a figure Soviet analysts refused to believe. Their own reconnaissance designs at comparable wingspans required nearly twice that mass because their alloys were heavier, their electronics bulkier, and their engines less efficient. American manufacturers could draw upon more than 60% of the world's aluminum output, and an electronics industry producing miniaturized systems at a pace the Soviets could not replicate until the late 1960s. What looked like aerodynamic wizardry was simply the natural consequence of a nation whose industrial base was designed to produce more than any competitor on Earth. The CIA understood this advantage intimately. They built not just one aircraft, but an entire logistical ecosystem, supply depots for titanium, fuel caches across Europe and Asia, custom pilots' pressure suits, mobile hangars, long-range transport links, and maintenance teams trained to rebuild a U-2 from scratch in days. When Soviet analysts later studied intercepted supply manifests from American bases, one internal memo described the U-2 program as having an infrastructure disproportionate to a single aircraft, not realizing that this disproportionality was the point. America won not by designing the perfect airplane, but by building the perfect system around it. Every element of the U-2 was a manifestation of something the Soviets could not quantify: industrial elasticity. The United States did not simply invent solutions, it industrialized them at scale. It did not merely design an aircraft, it designed an ecosystem that could support one. And when the U-2 took flight, it was lifted not by its wings alone, but by the weight of an industrial machine capable of turning improbable ideas into operational reality. The first overflight stunned the Soviet leadership, but what followed in the next 3 years shattered something deeper: the numerical foundations of their strategic worldview. Data, cold, undeniable, and merciless, revealed that the United States had not merely built an aircraft beyond Soviet reach. It had built an entire reconnaissance regime whose scale and tempo the USSR could not counter. Between mid-1956 and 1960, the United States logged more than 20,000 developmental flight hours, refining U-2 performance envelopes, life support behavior, thermal loads, camera stability, and high-altitude engine cycles. By contrast, the Soviet Union completed fewer than 2,000 high-altitude test hours on all comparable projects combined, including the experimental Yak-25RV and the E-66 series. The disparity was so extreme that Soviet analysts in 1958 questioned whether the American figures were even real. Their disbelief stemmed from a simple fact: the USSR did not possess the reserve flight test infrastructure to produce such numbers without halting other aircraft programs. America could test without sacrificing anything else. The Soviet Union could test only by pausing something critical. Altitude told a similar story. The U-2 consistently flew between 70,000 and 73,000 feet, with some classified profiles touching even higher. Soviet radar networks, in contrast, reached a reliable tracking ceiling of 54,000 to 57,000 feet in 1956, when atmospheric conditions were favorable. Above that point, radar returns thinned into intermittent specks, fading faster than software filters could stabilize. Soviet scope operators called them ghosts, unaware they were watching the faint electromagnetic shadow of the aircraft mapping their nation's most guarded secrets. Camera performance widened the gap further. The U-2's HICON A2 system produced imagery with ground resolutions of 2 to 3 feet, allowing the United States to count missile silos, measure storage tank volumes, assess reactor cooling systems, and map nuclear test sites with scientific precision. The Soviet Union, by comparison, relied on balloons, peripheral overflights, and low-altitude tactical photography, none of which produced strategic resolution images of American installations. While the U-2 mapped over 90 major Soviet military and nuclear facilities in its first months, Soviet intelligence could not produce equivalent coverage of even a single U.S. missile base. Production numbers deepened the humiliation. By 1959, the United States had built 53 U-2 airframes, with additional production lines prepared for variants. The Soviets built only a handful of experimental high-altitude concepts, none capable of mass manufacture. Every time the CIA added a new U-2 to the fleet, the Soviets responded by reshuffling interceptors, redeploying radar units, and rewriting defensive plans. The Americans expanded. The Soviets shuffled. The Soviets discovered the scale of their failure in a storm of classified briefings. One internal report described the U-2 as Nevidimy Samolot, the invisible aircraft. Another report submitted to a PVO commander concluded bluntly, "We lacked not the aircraft to intercept it, but the industrial base to create the aircraft to intercept it." This was not engineering defeat. It was ideological collapse. Soviet planners had assumed that central planning would eventually overcome capitalist excess. The U-2 proved the opposite. American excess, its redundant factories, its parallel R&D lines, its capacity to overbuild every subsystem, had created a machine the USSR could not pursue without destabilizing its own economy. Operational tempo delivered the final blow. Between 1956 and 1960, U-2s conducted over 200 reconnaissance operations across the Soviet Union, Eastern Europe, and peripheral borders. Many penetrated deep into regions the Soviets considered unreachable by any foreign aircraft. By the time Moscow realized what was happening, American analysts had already reconstructed an accurate picture of the Soviet strategic missile capability. Worse still, these flights revealed that the USSR had far fewer operational ICBMs than claimed. The supposed missile gap evaporated under American photographs, leaving the Soviet leadership exposed, not militarily but politically. In February 1958, a Soviet general wrote a confidential memorandum summarizing the crisis. "Our radars cannot hold it. Our fighters cannot reach it. Our missiles cannot lock onto it. The adversary sees everything and we see nothing." It was the closest a senior Soviet officer came to admitting that the balance of strategic knowledge had shifted irreversibly. The U-2's impact was not measured in altitude alone. It was measured in the acceleration it forced upon Soviet industry. The USSR redirected billions of rubles into radar modernization, missile development, and interceptor redesigns. Dozens of new institutes were created specifically to counter one aircraft. The Soviet economy strained under the weight. What the United States achieved with a few thousand engineers and a network of flexible factories required the Soviets to mobilize entire sectors. This was the true asymmetry. America needed innovation. The Soviets needed reinvention. And as U-2 imagery flowed into Washington revealing factories, fuel dumps, test sites, missile fields, submarine pens, and air defense grids, the Soviet leadership realized something devastating. Their shield, constructed with careful planning, secrecy, and years of industrial labor, was transparent. The Americans had peeled away the Soviet Union's strategic illusions with a machine that weighed less than a medium bomber's bomb load. The numbers offered no comfort. They offered only clarity. The United States had built not a reconnaissance aircraft, but a statistical weapon, a platform that converted altitude, industry, and persistence into strategic dominance. And every sortie widened the gulf between the two superpowers, proving that the gap between them was not technological but infrastructural. The U-2 did not merely fly above the Soviet Union. It flew above the Soviet understanding of what American industry could do. The U-2 did more than expose Soviet air defense weaknesses. It rewrote the strategic grammar of the Cold War. For decades, Moscow had relied on secrecy as a force multiplier. Concealed missile fields, hidden laboratories, camouflaged test sites, and a political mythology built on the belief that the USSR could outpace the United States through ideological discipline and centralized planning. But once the U-2 began its silent, high-altitude intrusions, secrecy, once the Soviet Union's strongest asset, became its most fragile illusion. The first strategic consequence was informational asymmetry on a scale unprecedented in military history. Within a year of the U-2's operational deployment, Washington possessed a clearer image of Soviet nuclear capability than the Kremlin itself. Analysts at the CIA's Photographic Interpretation Center reconstructed entire missile production chains, from ore extraction to final silo assembly, using high-resolution images taken from an aircraft that Soviet radars barely detected. They identified false construction sites, uncovered inactive test stands, and exposed inflated Soviet missile counts. The missile gap, the psychological weapon Moscow wielded to pressure NATO, evaporated under a flood of photographs. The U-2 became the foundation for a new kind of American power. Power built not on guesswork, but on empirically verified intelligence. Washington no longer needed to estimate Soviet intentions based on intercepted cables or defectors. It could observe, measure, document, and assess with mathematical precision. This accuracy stabilized American policy and demolished the notion that the USSR could bluff its way into strategic superiority. The second legacy was industrial revelation. The Soviets realized that the U-2 was merely the symptom of a deeper imbalance. The United States possessed an industrial infrastructure capable of producing leap-ahead technologies at will. To respond to the U-2, Moscow would need to overhaul its entire air defense network, creating new radars, new interceptors, new missiles, and new command architectures. But the Soviet economy struggled to support such reinvention. Where the U.S. built specialized systems with modular supply chains and parallel R&D, the USSR had to divert resources from civilian industries and frontline military units to fund projects that often failed to mature. The PVO's crash programs, boosted high-altitude fighters, early long-range SAM systems, redesigned radar arrays, consumed billions of rubles. The effort succeeded only in part, culminating in the S-75 Dvina missile system that would eventually down Francis Gary Powers in 1960. But the cost was catastrophic. Production delays across the aviation sector, reallocation of skilled engineers, and industrial bottlenecks that rippled through the broader Soviet economy. In attempting to counter a single American aircraft, the Soviets inadvertently weakened the very industrial base that had once sustained their strategic ambitions. Third, the U-2 forced the USSR into transparency on a global stage. Before the aircraft's missions, the Soviet Union could claim near-infinite military capacity without challenge. After the missions, any such claims risked immediate photographic contradiction. This shift in informational power disrupted Soviet diplomacy, limited its ability to manipulate foreign perceptions, and constrained its political leverage in Eastern Europe and the developing world. American policymakers now spoke with the confidence of a nation that knew exactly how many missiles its adversary possessed and how many it did not. Finally, the U-2 reshaped the culture of American aerospace dominance. The aircraft demonstrated that industrial abundance, when combined with scientific ambition, could generate capabilities beyond the reach of any command economy. It showed that the United States could not only innovate faster, but also operationalize that innovation with logistical precision. The program became the blueprint for future American reconnaissance platforms, from the SR-71 to spaceborne imaging satellites. The lesson was simple. Altitude was not merely a technical dimension. It was a strategic terrain, and the United States had mastered it. By the late 1960s, even senior Soviet officers conceded this reality. In a closed-door session of the Military-Industrial Commission, a general whose name remains redacted in surviving documents summarized the Soviet position with brutal clarity. We were not defeated by a plane. We were defeated by an industry. His statement echoed through the bureaucracy as both confession and warning. The U-2 had done what no bomber or missile could accomplish. It had pierced the ideological armor of the Soviet Union. It exposed a truth the Kremlin had spent decades suppressing. Industrial freedom, messy, redundant, wasteful, and unplanned, could outperform centralized discipline. American abundance, not American engineering alone, had conquered the stratosphere. In the end, the U-2 was not merely a reconnaissance aircraft. It was a mirror held up to two superpowers, revealing one built on excess capacity and the other built on rationed ambition. And as it traced its thin, glinting path across the upper atmosphere, the aircraft left behind a legacy that shaped every strategic calculation of the Cold War. Its altitude was astonishing. Its intelligence value was transformative. But its greatest legacy was the revelation that the true high ground of the Cold War was industrial.